Oh boy, I'm asking for it now. Well, everything else is getting debunked these days, so why not this too? Mind you, I'm just an amateur debunker, not a professional one. Not that I don't love these movies or TV shows or the books they're based on. Okay, let's get a clock on the board, if only for copyright infringement purposes. And we'll start now. First up, The Invisible Man. I started to question this one after my genius friend blew my mind so many moons ago. So even if a man, a person, could become invisible, and they still can't, they would have to be blind and deaf because light and sound waves would still have to hit their eyes and ears, respectively. I mean, sure, we can do a lot more with atoms now than they could in 1897, the year that the original H.G. Wells novel was published. We use nuclear material to power steam engines now, and we can split atoms, but we still can't make the visible invisible. Air was already invisible, and it'll stay that way. But who knows, maybe we'll pump enough CO2 into the air that we'll start to be able to see it swirling about. Okay, so how about the car in the 2002 James Bond movie Die Another Day? It's apparently covered with a mesh of tiny monitors and video cameras.
Adaptive camouflage. Tiny cameras on all sides project the image they see onto a light-emitting polymer skin on the opposite side.
Right. Well, even if you could get that to work, it would only work on one person at a time, which it does in the movie. Maybe if you had two people on opposite sides of the car. Unlike this scene, Bond and Q are close together at first, but as the car gets in front of them, the illusion wouldn't work because it could only work on one person at a time. And of course the car would have to know exactly where the person's eyes are in order to show the right pictures of the empty background. I'll be optimistic and say that AI could probably get the monitors to show the right pictures. Spoiler alert, I understand that the Invisible Man of the 2020 movie operates under similar principles, but the suit would have to be really quiet and really good for the up-close spying that goes on in that movie. Looks like a golf ball. Oh, excuse me. We move on from making atoms invisible to making atoms smaller from such sci-fi movies as the 1966 classic Fantastic Voyage, or the one I grew up with, 1987's Inner Space. These days it's the Marvel character Ant-Man who shrinks down to a very small size. Now, I may not remember much from high school chemistry, and I didn't take high school physics, but one of the unspoken principles of chemistry, and probably physics, is that the size of atoms doesn't change. According to Wikipedia, and speaking of which, most of this video is brought to you by Wikipedia. Wikipedia, please donate today so I don't have to. According to Wikipedia, the size of a typical hydrogen atom is 0.5 angstroms. And as with all of these movies, the science is explained as little as possible. So, a guy gets shrunk down to a much smaller size, which means that one of two things has to happen. One, the guy's atoms are shrunk down to size. Now, these smaller atoms reacting with regular size atoms, wouldn't that create like a massive explosion that would destroy the entire universe? Granted, that's a worst-case scenario. The destruction might in fact be very localized,
limited to merely our own galaxy.
Right. Or two, the guy's atoms stay the same size, but he's reconstructed as a smaller version of himself. Spoiler alert, that's the science of the 2017 movie Downsizing. And in that movie, once you're shrunk down, there's no going back. And that's just bad technology. Thankfully, either one of these possibilities is still well within the realm of impossibility. As is teleportation, a staple of shows like Star Trek, and all the Star Trek spin-offs and all the Star Trek movies. Doesn't seem to be in Star Wars. It's interesting. There's plenty of astral projection, traveling at light speed, but no teleporting in Star Wars. Of course, the real magic of that is getting the people to fade in and out. That's really more of a special effects thing, not a real-life thing. Well, one of the reasons why magically teleporting something from point A to point B would be impossible is that you would need some kind of coordinate system, and nature doesn't use coordinate systems. Maybe if you were merely teleporting something on Earth, you'd use GPS satellites to do it. Okay, so maybe the problem is solved with transmitters. If you can't instantly transport something, perhaps you can recreate it someplace else using the right molecular map. The right signal is broadcast to the teleportation pod, and the person or object being transported can be recreated. Now, a human being consists of about 10 to the 27th power of atoms. Let's just say it would have to be a really clear signal. And that's just for the atoms. You also need a way to encode how all the atoms are connected to each other. And you got to make sure the receiving teleportation pod is turned on. And that there's only one. Unless you want to make a bunch of copies of yourself. Of course, we should probably spend a few seconds on the 1958 movie The Fly, which is probably the most optimistic portrayal of the power of the computer that you'll ever see. Using 1958 technology, a human is broken down into constituent atoms. The atoms pass through tubes from one teleportation pod to another and is then reassembled. You remember how long it takes to put together a Lego set? Or IKEA furniture? Or if there's a leak in one of the tubes, God forbid. I think we're a few 100,000 years away from even beginning to worry about so cleanly mixing up the DNA of two creatures. No, we're still well stuck in the middle of the age of the forklift and the pallet jack for the time being. And finally, the big one, traveling either forwards or backwards in time. Well, we should start with the most villainous thing that Walter White has ever done.
It would violate the second law of thermodynamics.
Finally, a practical application for thermodynamics. Well, there was bound to be one sooner or later. But ultimately, I think it's the same problem as with teleportation. Space has no coordinate system, and time has no coordinate system, nor is there some master control of the universe that we'd have access to, with controls on it like go forwards, go backwards, or stop completely. Now, in the movies, it's usually some local wrinkle in space-time that we get access to. But if time travel were possible, and I don't think it is, I think it would mean that the universe is built like a tape recorder. Ask your grandparents. So if the universe is getting copied onto a giant audio tape, for example, how many copies of the universe are made per second? Now, according to Wikipedia, modern atomic clocks measure the vibrations of certain atoms at a rate of 10 to the 16th per second. Let's just say, for the sake of argument, that the universe is copied only once per second on a giant tape. And if you want to travel back in time, you can only do it at whole second intervals. Or maybe the universe is constructed like a jukebox, so going backwards in time is simply a matter of grabbing the right old record and putting it on the player where it becomes the new present. This way, no matter how far back in time you want to go, you just need the same amount of energy, say 1.21 gigawatts. But it seems like everyone would have to go back in time together. If a single person wanted to go back in time separately, you'd need a second jukebox to do it. So you have the present playing on the usual jukebox, and then a separate jukebox just for you, wherever you are in time. But traveling back in time is nothing if not fraught with danger, and there's the small matter of all those darn paradoxes to deal with. Back to the Future 2 is a perfect example of the bootstrap paradox, or take the grandfather paradox, for example. If, for example, someone were to go back in time, find their grandfather, and accidentally kill them, no, really, it was an accident, I swear. Well, depending on how thorough the corrective mechanism of the universe is, a person who time travels to the past and kills their own grandfather would thereby prevent their own birth, and would theoretically instantly disappear the instant their grandfather died. I mean, if time travel is that dangerous, why even risk it in the first place? But really, when you get right down to it, that's chivalry for you. They would technically have to kill their grandfather before they met your grandmother, and ... This all would seem to imply that, in addition to being a tape recorder and a jukebox, the universe is also a giant computer, keeping track of all families everywhere all the time, making sure that the grandfather paradox is being strictly enforced. Maybe we really are living in the Matrix. But these time travel paradoxes work two different ways. For the sake of argument, maybe there's hundreds of people traveling back in time all the time, trying to drastically change things, but nothing happens because time travel paradoxes protect our sense of constancy about the world. Or more likely, no one is traveling back in time. Therefore, no drastic changes are being made, which is why there are no sudden instantaneous changes to the present. Say an evil city planner were to go back in time and change the location of a really tall building. It never happens. At least not that we know of. I should probably have a separate video on time travel paradoxes, but for now I'll just say this. They got both sides covered. On one side, no change is possible. Like it says here on Wikipedia, time travel into the past need not be logically impossible, provided that there is no possibility of changing the past. On the other, you have Ray Bradbury's short story A Sound of Thunder, in which people pay to travel back in time to shoot dinosaurs. But there is also great danger of changing the future. Accidentally squish the wrong bug, and the present you came from is now totally different. Some say that time itself is just an illusion. If that's the case, time travel is the ultimate embodiment of that illusion. Hollywood seems to have already made the most of time travel, so the conversation is gently drifting towards multiverses, if only for the sake of originality. But if it's like Dr. Michio Kaku says, and we do indeed live in an 11-dimensional universe, and our own universe is about 93 billion light-years in diameter, how exactly are we supposed to get to those other universes? Wormholes? I thought wormholes were only for travel in one's own universe. But any shortcut will do, really. Anything else we can imagine. But that's just my opinion. I'm probably wrong about a lot of this stuff. And boom, with a few seconds to spare, no less. Oh, excuse me. Well, I wasn't sure how many there'd be. Anyway, so as always, thank you for indulging me, and thank you for watching.
Mighty glad you stayed.
I almost forgot. You got anything to add, George?
We're going to Norway in 2025.
That is freaking me out, man. I was going to do a thing about Zeno's paradoxes, but I found this paper online from Stanford that does such a good job. I really don't have much to add. So just read that thing.